In this video, we are going to focus on rational expressions and their domains. Rational number is a number that is written in the form of P over Q, where P and Q are both polynomials, where P and Q are both integers. For rational numbers, P and Q have to be integers, but for rational expressions, P and Q are polynomials and Q is not equal to 0. We have talked about dividing with 0. 0 divided by any number is 0, but any number divided by 0 is undefined. And it's a big no-no to do division with 0 because it makes your expression undefined. So 5 over 0 is undefined. You can remember it by thinking 0 over any number k is okay. It is just going to be 0, but any number k over 0 is knock out. Okay, you cannot divide with 0. So that's why we make sure that the denominator is never equal to 0. The top expression is called numerator and the bottom expression is called denominator. Remember the word d for down, d for denominator. Here's some examples of rational expressions. 3x plus 2 divided by x minus y. It's a polynomial in the numerator, polynomial in the denominator, so that is a rational function. Another example of rational function with polynomial in the numerator, polynomial in the denominator. Another example with polynomial in the numerator and polynomial in the denominator, 5 over x plus 7. 5 is a monomial, x plus 7 is a binomial. So we have a monomial divided by binomial in the third example. Also remember that if you ever have a negative a over b, it is same thing as negative a divided by b or same thing as a divided by negative b. So negative in the middle of the fraction is usually how we express, but that negative can go with the numerator or it can go with the denominator. It cannot go with both numerator and denominator at the same time. Okay, so all these above are equivalent forms of fractions. It's best to leave the final answer in the first form. That means you leave the negative in the front. Okay, not with the numerator, not with the denominator, but leave it in the front of the fraction. Also remember 1/2 a is same thing as a over 2 because the numerators multiply together. 1 times a, you can think of it as a over 1. 1 times a is a, 2 times 1 is 2. So half a is same thing as a over 2. Or 2/3 a, or we can say 2/3 x is same thing as 2x divided by 3. Okay, a rational expression written in the function form is called a rational function. For example, if we write it as f of x equals this. F of x equals x squared plus 2 over x minus 3. That's a rational function. Or another example can be 5x squared minus 3x plus 2 divided by 3x plus 1 equals g of x. So the function, it is a function of x. The independent variable is x in this case. Now let's talk about domain of a rational function, a very important concept, especially if you're going to take more math classes, you're going towards a calculus series. Domain of rational function will come back over and over. Domain of a rational function f of x, domain of a rational function f of x is set of all the x values are also called input values that yield a real number output value. Okay, all the x values that will give you a real y value, real output value. All the x values, all the input values that will allow you to have a real output value, that is called the domain of x. In easy words, domain of a rational function consists of all real numbers excluding the values that make the function undefined. Okay, the ones that make the denominator 0. So we want to include every single value other than the ones that make the denominator 0. Okay, we want to exclude the ones that make denominator 0. Very important. For a rational function, in order for it to be defined, the denominator cannot equal 0. So we want to exclude any values from the domain that make the denominator 0. Rational expressions and functions indicate division. Remember, division by 0 is undefined. This means that we must exclude any values or values of variable that make the denominator 0. domain of a rational function is set of all real numbers. Remember, say it with me. Domain of a rational function is set of all real numbers except for those which make the denominator 0. Okay. Here's a hint. If there's no variable in the denominator, domain will be all real numbers. That means that if there's a number 5, 2, 10, -3 in the denominator, that can never equal 0. So your domain will be all real numbers in that case. But if there is a variable in the denominator, then set the denominator equal to 0 and solve for the variable to get the illegal values. Illegal values are the not allowed values. Those are the values that will actually make your denominator equal to 0, and we don't want to include them. So we can find those by setting the denominator equal to 0. Domain will be all real numbers excluding the illegal values. Okay, let's look at some examples. Here's some examples. Find the domain of each of the rational expression. Express your solution in terms of interval notation and set builder form. Interval notation is when you're writing in terms of a parentheses. So interval notation can be written with the parentheses, and set builder form, where you say x is whatever this, such that x cannot equal. So that's how you express in the set builder form. Let's look at some examples. I'm going to be sticking with the interval notation for most part, but I will do set builder form for the first example as well. So look at your fraction. Do you have a variable in the denominator? Yes. So if there's a variable in the denominator, that means there's a danger that that denominator can equal 0. What value of the variable will make the denominator equal to 0? Go ahead and set the denominator equal to 0. So set denominator equal to 0 and solve for x. If I get the x alone, I get x equals -7. And I can see if x becomes -7, because x can be anything, if x becomes -7, I'm in trouble because then I'm dividing with a 0. -7 plus 7 is a 0. So here's a domain for me. We want everything. We want all real numbers, but we don't want x to equal -7. So my domain would be -∞ to -7. This open parentheses means -7 is not included, okay? Open parentheses means -7 is not included. If I had a bracket here, bracket would mean the number is included. Open parentheses means the number is not included, okay? So included and not included. All right, so that's my domain in the interval notation. This is the interval notation. And now I'm going to do in the set builder form, where it would be x belongs to real numbers such that x is not equal to -7. So there's a set builder form for the set builder form. This symbol R with 2 lines means real numbers. This means x can be any real number other than -7. Okay, let's look at example number 2, and I'm going to be sticking with the interval notation for the most part. When you're thinking about the domain, it doesn't have anything to do with the numerator. Okay, you don't even need to look at the numerator. Only look at the denominator and think about what values of x can make your denominator 0. So here it looks like if my x becomes 0, then I'm in trouble because 2 times 0 will be 0 and I will be dividing with 0. So I don't want to include here x cannot equal 0. That's my illegal value. 0 is the illegal value for x. So my domain will be -∞ to 0, union 0 to infinity. U stands for union. That means both of these sets are allowed parts of the domain. Okay, so the set of -∞ to 0 and the set of 0 to infinity. Union means these are all possible values of my domain. Okay. Next example number 3. I don't have any variable in the denominator. My denominator is 4, which I know can never equal 0. So no need to worry about this denominator. 4 can never equal 0. 4 is not equal to 0. And there's no way the 4 can equal 0. So that means domain in this case is all real numbers going from -∞ to +∞. There's a comma in the middle. Okay, these are the commas in the middle. negative infinity to positive infinity. Domain is negative infinity to positive infinity because there's no variable in the denominator. Let's look at example number 4. X plus 3 divided by x squared minus 4. Okay, x squared minus 4. Well, let's try to factor it. I think it might be easier to see once we factor. It is difference of squares. So what are the illegal values of x now? Illegal values of x are, well, we cannot have x equals positive 2 and we cannot have x equals negative 2. So my domain is all real numbers other than positive 2 and negative 2. Now I'm going to draw a number line just to help us write the interval notation. So on my number line, this is 0 and there's my negative 2 and there's positive 2 and it's going on forever. Now this is where my illegal values are. I don't want these. Other than these two, everything is okay for x. There's no other values of x that will give me a 0 in the denominator. So when you write in the interval notation, start from the far left, take a break at negative 2 because we don't want to include negative 2. Go from negative 2 to positive 2. We don't want positive 2 either. And then go from 2 to infinity. Okay, so this is going to be your interval notation for the domain in this case. We are excluding negative 2 and positive 2. We already said that parentheses means not included. So when you see this parentheses, that means we are not including that number. Bracket means we're including that particular number. So I'm using the open parentheses around negative 2 and 2. Don't worry about 0 because 0 is not an illegal value here. I just showed that to split the number line. Because if x becomes 0, then your denominator is negative 4, which is still a real number. Okay. Example number 5. 3 plus 2x divided by x squared minus 7x. What values of x are not okay? It might be easier to see once you factor your denominator. Okay. Once you factor your denominator, it might be easier to see. All right. So I can see here to find out what are illegal values. To find my illegal values, to find the unallowed values, I am going to set the denominator equal to 0. Set the denominator equal to 0 and solve it for x. X times x minus 7 equal to 0. Either x is 0 or x equals 7. We did talk about these when we first started factoring. So these are the two illegal values. So we don't want these to occur. We don't want x to equal 0. We don't want x to equal 7. Again, I'm going to draw a number line that might help us. So this is a 0 and this is a 7 and both are troublemakers. I don't want to include either of those in my domain. So start from far left, negative infinity, go up to 0, take a break, union, 0 to 7, take a break, and then 7 to infinity. And that's going to be our domain in this case for this rational expression. One more time, numerator has nothing to do with the domain. It only, you just want to make sure your denominator does not become 0. Any values that make your denominator 0 are not a part of your domain. Let's check out example number 6 now. The denominator looks like it's factorable, so I'm going to go ahead and factor x squared plus 5 over 9x squared plus 13. This is a quadratic. I'm going to factor it using x method. A times c goes here, b goes here. 9 times 4 is 36, and there's 13. Two numbers multiply to give you 36, add up to give you 13 are 9 and 4. Because my first number is 9, I'm going to divide both sides with 9x and a 9x. Let's see if I can simplify any of these fractions. I could simplify the first fraction but not the second. So now I am ready to write this denominator in the factored form. Because when it's unfactored, it's really hard to see which values of x will make it 0. So x plus 1 is my one factor. 9x plus 4 is my other factor. Now, to find illegal values, unallowed values, restricted values, all those are the values that make your denominator 0. So we set that denominator equal to 0. So x plus 1 times 9x plus 4 equal to 0. This means my two values that I don't want are -1 and -4 9. So these are actually, we don't want these values. These are the bad guys. They are going to make my denominator equal to 0. And you can think about it. If you plug x as -1 in here, you will be dividing with 0. Or if you plug in x as -4 9 here, you will be again dividing with 0. And that's a trouble. Let's go ahead and draw the number line to write the domain in the interval notation. So here's my -1, -4 9. How much is -4 9? Is it going to be on the left of 1 or is it going to be on the right of 1? -4 9 is -0.4. So that is somewhere here, okay? Somewhere between -1 and 0. And both are troublemakers. I don't want these numbers in my domain. Everything else is okay. Start from the far left. Take a break at -1. Go from -1 to -4 9, and then start from -4 9 and go all the way to infinity. Okay. Was 0 a troublemaker here? Not really. If x becomes 0, your denominator is 4, and which is totally fine, which is okay. Having 4 in the denominator, 4, it's still a real number. It's not going to be making your expression undefined. Let's check out number 7. 2x minus 3 over 12x cubed plus 34x squared plus 24x. All right, so I'm going to try to, well, you can first factor and then set the denominator equal to 0, or you can just set the denominator equal to 0 and then solve for it. Okay, so I'm going to set the denominator equal to 0. You can do them in any order. Okay, factor and then set it equal to 0, or set the denominator equal to 0 and then solve for x. Either way, you're going to get to the same restricted values. So 12x to the third plus 34x squared plus 24x equal to 0. Let's see. If there's a common factor in here, looks like there's a common factor 2x, which gives me 6x squared. 2x comes out. 6x squared plus 17x plus 12 equal to 0. Okay, now I'm going to try to, the inside expression is a quadratic trinomial. I'm going to try to use the x method to factor it. A times c is 12 times 6, which is 72, and 17 goes here. So two numbers that multiply to give me 72 add up to 17 are 8 and 9. 8 times 9 is 72, and 8 plus 9 is 17. My first number here for the trinomial I'm dealing with is 6. So I'm going to be dividing both of these with a 6x and a 6x. It is time to simplify the fractions, and both fractions I think are simplifiable here. So bottoms up method says 3x plus 4. So don't forget the 2x in the front. That is going to stick around. It's involving a variable, so you cannot just drop it. If it was only a 2, you could go ahead and divide both sides with 2. But because of the x sitting next to the 2, you cannot divide both sides with the x. So I'm going to carry it around. If you're really bothered by the 2, you can make the 2 go away by dividing both sides with the 2. Okay. 3x plus 4 is my one factor, bottoms up, and 2x plus 3 is my other factor. So let's think about what are the illegal values here, what are the restricted values, what are the not allowed values to be the part of the domain. So zero product property says once product of 3 terms is 0 or 2 terms is 0, one of them must be 0. We have 3 terms here. So either 2x is 0, or 3x plus 4 is 0, or 2x plus 3 is 0. So from the first one, I get x equal to 0. From the next one, I would be solving it for x. It turns out to be -4/3. And it leaves me with, I did 2 steps together. Here we go. 2x is -3. X comes out to be -3/2. So there's my bad guys. These are the people I don't want, who are going to make my denominator 0, because that makes my expression undefined. So we don't want these 3 numbers in our domain. Okay, let's go ahead and draw the number line. It's easier to draw the number line and then write the interval notation, because it has to follow the correct order going from left to right on the number line. Okay, my illegal values are x equal to 0. And then we have 4/3. 4/3, what's the value of 4/3? Let's see. 4/3 is going to equal 1.3. So this is 1.3. And then 3/2 is going to equal 1.5. So this is 1.5, negative 1.5. All right, so let's go ahead and mark them. Just for my own, this is negative 1. More space. Okay, number line here. This is negative 1. So this is where I would have negative 1, negative 3/2, and this is where I would have negative 4/3. Okay, so negative 3/2 and then negative 4/3. I'm not happy with the way it looks, too crunched. So this is 0, number line. This is negative 1 and negative 3/2, negative 4/3. Okay, so in the right order on the number line. Now these are my unallowed values. These are my restricted values. I don't want any of these. Negative 1 was not an unallowed value. I just did that to show you the number line, and you don't have to express negative 1 on the number line. You can totally skip it. It's not required to be there, but these are the unallowed values. Now let's go ahead and write the domain. We're going to start on the far left, which is negative infinity to negative 3/2, union negative 3/2 to negative 4/3, union union negative 4/3 to 0, union 0 to positive infinity. Okay, all these, so there's gonna be, these are all the commas in the middle. So there's 4 set of different parentheses. So your domain is divided, your number line is divided into 4 regions of allowed values. So the ones I'm going to mark in yellow are allowed. All these values are allowed. All these values are allowed. All these values are allowed, and all these values are allowed. So there's 4 regions for which every single number that falls in the range is allowed, but then there's also big time troubles, which I'm going to mark big green now. Okay, so these were big troubles, and these are the ones we are excluding, right? That's all about domain of a rational expression. Just to summarize, remember, rational expression is an expression of the form P over Q, where P and Q are polynomials. They can be monomials, they can be binomials, trinomials, or polynomials, both of them. And when we think about domain of rational expression, we don't want the denominator to equal 0, because division with 0 makes your function or expression undefined. And all the other values of variable will be allowed as long as your denominator does not become 0.